So yesterday we took a look at simplifying radicals, but most of the examples we took a look at, we had perfect roots. Everything worked out to be nice whole numbers. We didn't have to do any messing around with things to get it to have a good looking answer. However, today we are going to be taking a look at examples of non-perfect roots. So if we leave things as they are, we end up with decimals and all of that. What I'm going to show you today is how to make those answers, those non-perfect answers, look much neater and much more organized in the way that I want you to write them out. So first off, this example here, the cube root of 16. If you were to enter this in your calculator the way that we did yesterday, 16 to the power of 1/3, you would get a big old decimal and it would be very, very ugly. We have a way of splitting this up in order to make it much simpler and much prettier. So first off, if a radicand is not a perfect root, for instance right here, 16 is not a perfect cube root, then we want to split it into the largest perfect root and its other factors. So for instance, I can split 16 up into 8 and 2. Because 8 is a perfect cube root, and 2 times 8 gives us 16. So I'm going to write this as the cube root of 8 times by the cube root of 2. So right here, I split this up because these two multiply back to my original. So I've got 8 and 2. I know that the cube root of 8 is equal to 2. And when we simplify that, it gets rid of the radical sign. It comes outside of this little box here. So this right here goes to a regular 2. And then this right here stays like it is, because we can't simplify this any further. And so our answer would be 2 times by the cube root of 2. We just take what we start with originally, if it's not a perfect root, we split it into two things, with one of them being the largest perfect root, less than our number, and then we simplify that root. We leave the other one as it is. So for instance, this 16 here splits into 8 and 2, because 8 is a perfect cube root, and when we take the cube root of 8, we get positive 2, and we leave this second one as a radical there. Let's take a look at what happens when we have variables. So variables are very similar. If the power is not divisible by the index, we want to split into two bases, with one base being divisible by the index. Now the difference here is before our two numbers multiplied to what we started with. In this case, our two numbers are going to add to what we start with. So for instance, 15 is not divisible by 4, but the biggest number that's less than 15 that is divisible by 4 is 12. So I'm going to split this into x to the power of 12 and x to the power of 3. So now we have one radicand here that has a power that is divisible by 4, and our other one is not. It cannot be simplified. So we're just going to simplify this first one right here. And if you remember, we divide our power by our index. So 12 divided by 4 is going to give us x to the third power. And then the second part stays the same. So our final answer is x to the third times by the fourth root of x to the third. Now it's just a coincidence, but it won't always work out where we have the same power out here and in here. We will regularly and most of the time have two different powers. It just happened to work out where I got the same power outside and inside. Let's take a look at two more examples where we put both of these things together. All right, here we see we've got some numbers and variables. We're still going to work this the same way that we were working yesterday, but we're going to add in the information that we learned today. So first off, we need to do the cube root of 250. If you do that in your calculator, it's going to give you a decimal. So I need to split this up into a perfect cube root and some other number that multiply together to get 250. Well, I can split this up into 125 times by 2. So I'm going to write it out as a cube root of 125 times by the cube root of 2. So this takes care of my first number right here. Now I need to work with this x here. Well, this 12 can be divided by 3, so we're not going to change anything. We're going to leave it as the cube root of x to the 12. But lastly here, we've got y to the 13th. Well, 13 can't be divided by 3, but I can split this y to the 13 into y to the 12 and y to the 1. So I'm going to write that out. So we got these two numbers from the 250 because 125 times by 2 is 250. The x we left by itself. We didn't split it up because 12 can be divided by 3. And then the y's here we got because 13 isn't divisible by 3, so we split it into 12, which can be divided by 3, and 1. Now we're going to simplify everything we can. Everything we simplify is going to go in the very front. So first off, the cube root of 125. This should give us 5. No more root here, so I'm going to cross this out. Right here, this won't simplify, so we're going to leave that there for the moment. I want to get everything that simplifies first. Next, we're going to do 12 divided by 3, which gives us x to the 4th power, no more root. And then right here, we have 12 divided by 3, which is also 4, and so now we have y to the 4th power. So the only things that are left are things that don't simplify. I'm going to put both of these under one cube root. So I've got my cube root symbol here, and I've got a 2 and a y to the 1, or just y. And so this is my answer right here. It's real important to make sure that this number right here for your index doesn't match up with your powers, because I don't want you to think of this as the 43rd root or the 43rd power. You need to make sure that they're two separate numbers there. We're going to do the same thing down here with this one. We can't take the square root of 27, so we need to split it up. This will give us 9 and 3, because we can take the square root of 9. We can't divide 7 by 2. If you remember that if there's no index shown, it counts as an index of 2. We can't divide it by 2, so we're going to make this a to the 6th and a to the 1. And lastly, we can divide 10 by 2, so we're just going to leave the b as it is. Now we're going to simplify. So the square root of 9 is 3. Can't simplify square root of 3 at the moment. We can simplify this. 6 divided by 2 gives us a to the 3. A to the 1 won't simplify, but b to the 10 will, which will give us b to the 5. So now everything that's left is not simplifying, and so that's going to go inside the square root. And so 3a to the third, b to the fifth, square root 3a is our solution.